Hello, good morning all. I am Shreyas Charola, working as Assistant Professor in Department of Electronics and Communication at Marwar University. Today, I am going to discuss about the Clipper circuit. So today's topic need to be discussed in this video lecture is what is Clipper circuit, what are the applications of the Clipper, types of the Clipper circuits, steps to solve Clipper circuit problems, biased Clipper example and unbiased Clipper circuit problems. Now let us talk about what do you mean by the Clipper circuit. So the Clipper circuit are used to remove the part of a signal that is above or below some reference line. What do you mean by some reference line? That is nothing but a DC. Okay, let's suppose consider this is what I have, a Clipper circuit made up of diodes, and this one is, let's suppose, is the input, and from here I am getting the output. If I will give the input, which is the AC signal, to the Clipper circuit, output might be only positive cycle, there is no negative cycle at all, or it should be only negative cycle, there is no positive cycle, or you can also say that some part of positive, then it will be the straight line, then I will get a negative cycle, the complete negative cycle. Okay, what happens over here? During this, after passing the AC signal to the Clipper circuit, the negative part of a circuit has been clipped, and here the positive part of the clip. Here in this example, some of the positive part of the positive cycle has been clipped, and rest of the signal as it is. So the Clipper circuit is an circuit where the unwanted parts of your AC signals can be removed. It also called as a limiter, or it also called as an amplitude selector or slicer. There are some few applications of the Clipper circuit. Let's suppose if I'll talk about this one is nothing but a rectifier. This is the full wave rectifier and the half wave rectifier, which is made of a diodes. Here if you look at the circuit, it is nothing but a half wave rectifier. If you apply the AC signal to the half wave rectifiers, which is made up of a diode and resistor, and if you measure the output from this across this resistor, what you will get? The negative will be clipped and only the positive cycle will come. That's why this circuit we call as a negative Clipper. Now for the circuit, same is a half wave rectifier. Again, when I apply the input, the AC signal to the circuit, and if I measure the output across the load, the positive cycle has been clipped. That's why it's called a positive Clipper. Here again it's a half full wave rectifier, and this one is nothing but we call as envelope detector. So in the types of circuit, if you look, there are the Clipper circuit are two types. One we call as a bias, other we call as an unbiased circuit. And again the bias is divided in two parts: bias positive Clipper circuit, bias negative Clipper circuit. Unbiased is also divided in two parts: bias positive and bias negative Clipper circuit. Now first let us take the category of unbiased Clipper circuit. So there are the few steps to remember to how to solve a unbiased Clipper circuit problem. First, step 1, what you need to identify? First, you need to identify whether the circuit is for bias or unbiased. What is the second step? Draw the equivalent circuit for case 1 when V input is greater than 0 reference line. And what you need to do? You need to find the output voltage across the load resistance. Draw the equivalent circuit for a case 2 with V input less than 0 reference line and find the output voltage. Based on the step number 2 and 3, draw the input and output waveforms to find out whether it's a positive or negative. And in the step 5, comment whether the circuit is a positive Clipper or a negative Clipper. Let's suppose take one example which is made up of a diode and a resistor, and across this I am finding my V out, that is output voltage, and the input voltage which varies the AC signal from 10 to -10. Now see, this AC signal is moving on a DC line, that is a 0 DC line, correct? And above that we have the AC signal. Okay, where's step 1? It is directly clear that it's unbiased circuit. There is no DC supply in the circuit, that's why it's called a unbiased Clipper circuit. Now look at the case 1. Is V input is greater than 0, that means this is a 0 reference line. If it is greater than 0, that means I am talking about this part. That means let's suppose this one is a ground. With respect to ground, the diode have a 0 volt over here. At what voltage the diode will be forward biased? If the voltage which is applied on the P side should be greater than 0. That means all from 0 to 10, 10 to 0, the diode will be forward bias and the current will start flowing in this. That means V out will be equal to V in. That is a V out will be equal to V in at the output, first output. Now let us take the step 3. What I need to do? V in less than 0. Less than 0 means this is 0 reference line. Less than 0. Which are the voltages? These are the voltages we have. That is a V in less than 0. Now for this case, if I will draw the equivalent circuit here, again this one is 0 volt. Now all the voltage what it applied over here, that is a 0, minus 1, minus 2, minus 3 up to minus 10 and 10 to again 0. That means this diode remains in reverse bias. If I draw the equivalent circuit, this will be the open circuit, and again I have a resistor. For the negative voltage, the terminal will be reverse. Okay, now here this diode will be open circuit, so current will not flow over here. That means all the voltages what we are getting, all the voltages, if I mount V out, if there is no current flowing in this circuit, that means voltage across this resistance equal to 0, because V equal to IR. So V out will be equal to 0 volt at case 2. Okay, this one is for case 2. Now draw the output waveform. Let's suppose this is the input and this one is output. This is nothing but a 0 reference line. Okay, for the positive cycle when I applied, what is the output? Same as a V in. So same as a V in. Now look at over here. When I apply a negative part, what is the output I am getting? 0 volt. That means at that particular voltage I don't have. Let's suppose if I will take another cycle. Again, for the positive cycle, what I will get as a V out equal to V in. For the negative part, again it's a 0 volt. So again, this one is nothing but which part has been clipped? The negative part has been clipped. That's why it's called as a negative clipper. Now for this positive clipper, again if you follow the steps you will get the same output and it will get the positive clipper. Let's suppose this is the input I am applying to the circuit. Again, due to this ground, this one is a 0 volt. You need to first comment on the circuit whether it's a bias or unbiased. There is no extra DC supply, that's why it's a unbiased clipper circuit. What is the step 2? That is for V in greater than 0. Now this one is 0 volt, understand. For the P side is 0. Now we apply this greater than 0 means which is the voltage I am talking about? I am talking about this voltages. If it is greater than 0, that means if you apply the positive cycle 0 to 10 volt and again 10 volt to 0 volt, because 0 to 10 volt and 10 volt to 0 volt. Now we apply this cycle, the positive cycle across this diode. Again this is 0 volt and this is up to 10 volt, 0 to 10, 10 to 0, diode remains in reverse bias. So it's an open circuit. So what is the output at this case? V out equal to 0 volt. Will not get for the positive cycle. Now in the step 3, if you apply V in less than 0, what do you mean by V in less than 0? That means I am talking about, so in the step 3, if V in is less than 0, I am talking about this part. Okay, if the step 3 V in, that means which voltage I am talking about? 0 to minus 10 volt and 10 to again 0 volt. So if you apply over here 0 to minus 10 and again minus 10 to 0, what happens? 0 volt is much greater than all the voltages what we are applying over here. That means this diode will be in the forward bias and the current will flow in this direction. What you will get the output? You will get the output over here across the drop of resistor. That means during this V out will be equal to same as a V in. Correct? Now if I draw the step 4, for the positive cycle, the output equal to 0. But during the negative cycle, my output is same as a V in. That's why if I want to comment which type of clipper it's a step 5, this one is a positive clipper because the positive part has been clipped. Now let us discuss about the second category, that is nothing but a biased voltage. Now again let's discuss about what are the steps to solve the biased clipper circuit. Identify again the circuit is biased or unbiased. Now here there is one changes in the step 2. Draw the equivalent circuit for case 1. Now V input for greater than the bias voltage. There is no 0 voltage. Okay, V in should be greater than the bias voltage. Again for the step 3, V in less than the bias voltage And what is step 4? Draw the input output waveform for the C based upon step 2 and step 3, because at both the stage we had find the output voltage for V in greater than the bias voltage and V out less than the bias voltage. And last, comment on whether it's a positive bias or a negative bias. Let's suppose consider this example. What I have, this is the input which is varying from 0 to 10 to minus 10 as an input as a AC signal, a diode, resistor, and this battery file connected. That means that's why it's called as a bias clipper circuit. Okay, now due to this 3 volt, positive, negative 3 volt I can write it over here, 3 volt with respect to ground. So this voltage will be equal to, let's suppose, 3 volt. See, you can only comment on a diode once you have the voltage on the other side, whether it's a forward bias or reverse bias. So I am considering here, due to this battery terminal I am considering, and there is less drop across this resistor, that's why I am considering due to this battery it's a 3 volt. Now here, when I have step 1, it's a bias clipper circuit. Now at the step 2, what do you mean? It's a V in greater than the bias voltage. What is the bias voltage I have? The 3 volt. V in greater than the bias voltage. Okay. Now if I have the 0 to 10, 10 to 0, this one is nothing but draw a one DC reference lines with the 3 volt. That means at the step 1, if I am talking about V in greater than a 3 volt, that means this is 3 volt reference line. That means I am talking about this red part, which is okay, V in greater than, that means a voltage I will consider only 3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 5, 4, 3, okay, 3 to 10, 10 to 3 again. That is something but a positive cycle what I apply. So during the positive cycle what I apply, this is 3 volt. If I apply the 4 volt over here, 3 to 10 and 10 to volt, what happens? The diode will be in the forward bias. If I draw the equivalent circuit, let's suppose this one. Now the diode, I am considering the practical diode. So the 0.7, a resistor, a 3 volt battery, and a resistance, and in this one is also circuit. From here I am applying V in, and from here I am taking my output. Now when the current starts flowing from the resistor to the battery, again, if it is, what are the voltage over here, that will be dropped among the resistance, and the battery is of 3 volt. That means what are the voltage you apply? Let's say 4 volt I apply, 3 volt is already over here and 1 volt will be over. That's why the V out, it will equal to V in. For which case? For V in greater than 3 volt. Let's suppose, consider now here the same diode direction, this is 3 volt. Now apply less than, which case you am talking about? I am talking about the V in less than 3. That means I am talking about which part? I am talking about this blue color shaded part. In less than 3 volt, here what are the voltage I will apply? I will apply a 2.9, 2.9 to minus 10 and minus 10 to again 2.9. That means if I apply this voltage 2.9 to minus 10 and minus 10 to 3, this is voltage what I applied. So here is the 3 volt. Now if I apply the plus 2.9 to 10 volt and 10 volt 2.9, this diode remains in the reverse bias. So what is the equivalent circuit? This diode is open circuit. I have resistor, I have battery, and what is the output? This output here positive minus, let's suppose VR, and here it's a 3 volt. Apply the loop over here if you can't get the idea. What is the negative? Always take the second sign first. Positive to negative, take plus V out. Now if you apply the input over here V in, but the current will not flow because due to the open circuit the voltage across the resistor is also 0. So V out negative VR minus 3 volt equal to 0. So V out minus 0 minus 3 equal to 0. What is the V out? V out will be equal to 3 volt in a case 2. Now what I need to step 4, I need to depends at the first step 2 what I got, and the step 2 I got V out equal to V in, and a step 3 what I got is a V out equal to 3 volt. Now look at over here. This is what the characteristic what I had drawn, and this is nothing but a 3-volt reference line. Now here also I am just drawing the 3-volt reference line. Now when I apply the input which is greater than the 3 volt, my output is the same as a V in. That means this is what my output, if the case is V in greater than 3 volt. If V in less than 3 volt, then what is the output I have? As the same as a 3 volt. That means for this particular voltage I have a constant 3 volt battery. Again, which part has been clipped? Negative part has been clipped. That's why we call it a negative bias clipper circuit. Okay. Let us discuss about the second example. What I had done, just I had changed the polarity of battery. Now instead of 3 volt, what you need to do? You need to consider minus 3 volt over here, and the step 1 again, it's a biased clipper circuit. It's a biased clipper circuit. If I look at the waveform, minus 3 volt, that means I first draw the minus 3 volt reference line. That means if I talk about the step 2, that is a V in greater than minus 3 volt. That means what I am talking about? I am talking about these waveforms and these waveforms. There is a V in greater than, and what should be the output? Let's suppose here it's a minus 3 volt. If you apply greater than minus 3 volt, that is a minus 2.9 to 10 volt and 10 to minus 2.9. What is the voltage you will get? This voltage diode will remain in the forward bias, because this voltage, let's suppose this one is a VA and this one is a VB. So it's a VA greater than VB, diode remain in the forward bias. So again have some drop over here, the VR and the battery terminal. What is the output you will get? Output is the same as a V in. Now what about the step 3? It's a V in less than minus 3 volt. That means which I am talking about, which diagram I am talking about this part. That is a voltage what you apply, that is nothing but a, I am talking about minus 4 to minus 10 and 10 to again minus 4. Okay, so for that all this voltage which is minus 3 volt at this side, that will be the greater than this all the voltages. Again the diode will be in the reverse bias. If diode is reverse bias, no current will flow in this loop. Again the voltage across the VR, that will be equal to 0. So at this particular case V out will be equal to minus 3 volt. Now let us draw the output characteristic. This is what I have the input, and now before drawing the output I will draw a one DC line that will be equal to minus 3 volt. So I am talking about these voltages when greater than minus 3 volt, it's same as a V out equal to V in. So what is the output I will get? Output I will get, sorry, it's a okay. What about the when you apply the step 3 for this particular part? What I have, V out equal to minus 3 volt, so it's a minus 3 volt. Are you getting or not what I mean to say? Okay, so this is what the introduction and how to solve the clipper and bias clipper and unbiased clipper circuit using the steps what I had said. Thank you for listening the video.